I also wanted to touch on part of chapter 37, um, because we do rely on our ecosystem for some of these nutrients that we need. They don't just come from biotic, but also from abiotic reservoirs. Um, so we're not going to talk about the community structure and dynamics so much. We're going to talk about ecosystem structure and dynamics. Um, so when you're looking at ecosystems, um, and we touched on this, I think, in chapter one, you've got the chemical cycling that's happening. And I've mentioned this a couple of times now, that these chemicals that are just, they're reused over and over again, they're recycled over and over again. There's nothing added, and nothing basically taken away. Um, Energy needs to be resupplied all the time. Um, all the energy comes from the sun. It's converted by plants into chemical energy, and then secondary, tertiary consumers pick up this energy, and at each level, organisms use some of the energy to live, right? And then they lose some of the energy to heat. Um, and so this is where, this is how energy works. So let's talk about the energy for a little bit here. So the way the energy works is the primary production is the conversion of the solar energy to chemical energy. So it's what we can capture, right? It's what's able to be captured. First of all, what gets there, and then what can be captured. Um, and so the primary production is very different in different environments, and depending on the level of primary production that can be produced in a specific area, that limits how many animals can survive there. Because at each level you have um, so you've got the caterpillar that eats plants. It needs some calories that it uses, right? Um, and then whatever it leaves behind um, can then be utilized again. And for each producer, the producers have, they produce about, I don't know, X number of 10,000 calories. Then about 10% of that um, can then be utilized again, because it's not used up from the next one up, and the next one and the next one. So you can have the more kilocalories of sunlight you come in, the more layers of a pyramid can you have that can be sustained by the energy that's in that food chain. Um, this explains the ecological cost of meat. Um, so if the producers are, if the corn is the producer and we are the primary consumers, there's a lot more left over for others. So we can support a lot more people if we're leaving out the cattle. Um, this is true if you're making this calculation just like that. However, if instead of cattle, um, if you're utilizing land that otherwise cannot be farmed, for example, if you've got goats that can graze places where humans can't do anything about, um, then we're utilizing areas that we otherwise wouldn't utilize. So pure vegetarian is probably also not the answer. So it's probably a little more complicated than what we normally like to think about. Um, then with biotic and abiotic reservoirs, this is carbon. Carbon finds its way all over different reservoirs. The CO2 in the atmosphere is captured in photosynthesis, um, passed along to primary consumers, in the form of energy, right? In the form of energy in glucose and other things. Um, and then the carbon goes into a number of different places. Through cellular respiration, goes back in the atmosphere. Through death, it becomes part of the detritus, and it gets decomposed, also goes back into the air. When we burn fossil fuels or wood, we're burning CO2 in the atmosphere, gets captured again by the trees, and the cycle starts all over. So that's the CO2, that's the carbon cycle. Um, the phosphate cycle has to do with rocks and weathering in rock. So it goes into organic soil from there, and is then either goes back into rock or is assimilated mostly by plants and then with animals and the detritus and off us with decomposers in the soil. Nitrogen, in large part, depends on the presence of nitrogen fixing bacteria that are able to fix this nitrogen and make sure that plants can pick it up. Um, Decomposers have a role in this too, and then denitrifiers. So this has a lot to do with where a lot of bacteria are involved in this particular cycle. But we also have um, the nitrogen is primarily in the ground. So this is why we fertilize with things like nitrogen and those kinds of things. If plants can't get enough of those are rate limiting factors. However, if we're not careful, then we're over fertilizing these lands, and we're then causing major problems with the amount of oxygen in the oceans, which is then going to cause a major problem with our ability to have fish survive in those areas. Um, so, essential for our well being, fresh water and some foods. We need to recycle our nutrients, or nutrients are recycled in ecosystems. Um, Ecosystems need to decompose our waste for us and regulate climate and air quality. Um, and so it's not that we don't have water, it's that we don't have fresh water. And we need to make sure that we have these types of landscapes available that give us the ability to buffer some of these provide some of these ecosystems that we need for that. Um, and so this goes in direction of the sustainability, where we've got to make sure that we are good stewards of our earth, because it's not gonna be able to be sustained if we don't. And that's it for this part of chapter 37.